Natural Hazards Research Australia's new Extreme Fire Behaviour Knowledge modules support the ongoing professional development of experienced fire behaviour analysts, environmental prediction services meteorologists, and decision support meteorologists. These modules will help these experts evaluate extreme fire behaviour risk and provide operational guidance and fire weather intelligence. This information is vital for informing operational response and ensuring fireground safety. As part of the Centre's commitment to translating research into practice, these modules represent the practical application of research conducted in collaboration with the Bureau of Meteorology after the destructive 2019-2020 Black Summer fire season. Using advanced supercomputer simulations, the research, along with the subsequent knowledge modules, were developed with Dr Mika Peace at the Bureau of Meteorology, Predictive Services Specialist Chris Morton at the Department of Energy, Environment and Climate Action in Victoria, and Curio. Meteorology and bushfire behaviour models were compared to understand the processes that drive challenging and destructive fires, as well as both fire and weather change in response to each other, presenting extraordinary challenges for firefighters.
We've done 3 online training modules. There's about 6 hours of content in total. And it's really capturing everything that we learned from the Black Summer fires. So we did simulations of 5 different fires around the country. And it's turning that into training and learnings on the extreme fire behaviour for practitioners. Key audience for the modules are our fire behaviour analysts in Australia and our fire meteorologists. And we've done these modules after the Black Summer fires to really look at a couple of processes that were really key in driving some of the major extreme fire events that we saw. So we've used operational images and graphics and figures so that they're really directly linked into the same kinds of tools and the same kinds of visuals they'll be looking at operationally. Well, in the modules, they'll learn about the environments that are favourable for low-level jets and for fire-generated vortices and for extreme fire behaviour. And they'll learn through the modules the kind of ingredients to look for using operational tools, which will help extreme fire behaviour predictions and improve the safety of decisions that are made in relation to communities and also to firefighters who are on the ground. The focus of 2 of the modules is low-level jets and fire-generated vortices, and both of those phenomena were associated with fatalities during Black Summer. For the low-level jets, it's really about what tools they have available to identify the processes and the locations and the timing of when they occur, but also learning about how low-level jets can interact with a fire plume. And that's something that we haven't really seen before until we've run the coupled fire atmosphere simulations on them. There were a number of fire-generated vortices that occurred during Black Summer. A lot of the footage was on the media. But where in Green Valley there was a fatality where a fire truck was overturned and a young firefighter was killed. And that was associated with a fire-generated vortex with tornado-strength winds. So one of the things that we've really embedded into the learning in the fire-generated vortex modules is what kind of ingredients led to that and what can people look for in future and what are the kinds of environments that these really dangerous vortices form in.